understand what is the meaning of Tn and Sn and all that. Okay, we'll take again the simple one. 2, 5, 8. What is the next one? 11. Next term. 14 and so on. Okay, this is the AP. Now remember, you already know if you add 3 and all, you'll get something, right? So now this first thing is like the first term, T1, also called A many times. Okay, and the difference, the common difference with plus 3, which you are having, is called T. Okay, second term is T2, third term is T3 and so on. If you can find a general rule in terms of n to find these terms, that is known as Tn. Can you think of a general rule, a formula where I just substitute the value of n, I should get that term? Think about it. As you can think, if you try to think of it straight away, it's kind of difficult, isn't it? So let's try to see how we can get to a formula for this particular case. Okay. Now, I'll delete all this and let's start from the basics. So first term, we call it A. The common difference, we call it D. So second term is A plus D. Third term is A plus 2D. Fourth term is A plus 3D. And so on it goes. So this is my first term. This is my second term. This is third term. This is fourth term. Now, just looking at this, can you guess what is the eighth term?
Yeah. A plus 17.
Excellent, isn't it? So now, t to the power n if I am doing, it should be a plus 1 less than this number, isn't it?
Yeah.
So it should be a plus n minus 1d. This is the nth term for a AP. This is the nth term for a AP. Okay, now let's come to that. We had, I think, 3. Okay, I forgot, but anyway, let's take 3, 6, 9 and so on. Suppose it's like this. So the general term for this will be Tn is equal to A, which is 3. I'm using this formula, see. Instead of A, I've written 3. N minus 1, I'll write as n minus 1 itself, because I'm trying to get the formula for nth one. So n I don't replace. Into D, which is 3. Now that is 3 plus 3n minus 3. Now see this cancels? Quite obviously it is 3n, isn't it? Now how do I check if it is correct? Well, but just by looking at this, I know the fourth term is 12, isn't it? So let me find T4. So this is 3n. T4 is 3 times 4. So that becomes 12. Got the idea? So fourth term is 12. Now almost every kind of sequence can have a Tn. We have taken example only for one type of sequence, which is known as arithmetic progression. Okay. Now what is Sn? Now Sn means sum of n terms. So suppose my sequence is 3, 5, 7, 9 and so on, so on, so on. Suppose I have to find the sum of n terms, then what do I do? So now we have to derive what is Sn, which is even more interesting. Okay, let's try to do that. Okay. Now you'll see how beautifully this is done. We'll take the first term, A. Second term is A plus D. Third term is A plus 2D and so on. Till the last term, which is A plus, if it's n terms, A plus n minus 1t. That's the last term also, isn't it? So if I can find this whole series, I'll know the sum. So let me call the sum of this as S of n, sum of n terms. Now, they had a lovely trick to solve this. What they did, they said, okay fine, whether I add it up first term, second term, third term till the last term, or I add it up as last term, second last term, third last term till the first term, the same thing. So I'll write this series ulta. I'll say A plus n minus 1t plus A plus n minus 2t and so on and on and on and on till we get A. So what's the big deal, right? We are worried. But you know what? No, see, you are summing up a series, right? So it's like first term plus second term plus third term plus last term. Goes on till last term. So they said, okay, instead of counting this way, let's count this way.
Yeah.
Last term, second last term, third last term and so on.
Yeah.
So this is the last term.
Yeah, second.
Second last term will be like this. And so on till you get the first term. So what is the big deal? I'll show you what the big deal is. I'll take the last term and the first term and add them. What will I get? 2a plus n minus 1d. Correct?
Yeah.
Okay. Now I'll take the first term and last term, add it. I'll again get 2a plus n minus 1d. Funny, isn't it? Now I'll take the second term and the second last term. That is a plus d, the second term. Second last term is a plus n minus 2d. Did you understand why it will be n minus 2d? That is kind
Second
of,
last.
yeah, second last. So like, see, this is the last term, the nth term. So it has to be 1 less than
Yeah.
n. The previous term will be n minus 1th term. So it has to be 1 less than n minus 1. That's why n minus 2 comes. Now we expand this. So a plus d, and this is a plus nd minus 2d, right? This part. Now I forget this. This has to be added to this. So this will become 2a plus nd plus d minus d is how much? Minus d. So if I take d common, I'll again get 2a plus n minus 1d. See, what a funny thing. If I take the first term and last term, second last term, third last term, and so on, I'll always get a 2a plus n minus 1d. Now there are n different terms, isn't it? So that means when I add all this up, I'll get n terms which are 2a plus n minus 1d. So what we do is, we say, okay, we have written the first one straight, the second one in the reverse. Now what we do, we add the two equations. So 2sn, 2 times the sum, obviously sn plus sn. Now first and last term we know will come to 2a plus n minus 1d. And we also know that every other pair will also give 2a plus n minus 1d. So how many times will this occur? How many terms are there? N times. So it will occur n times. So we can say that Sn is n by 2 times 2a plus n minus 1. Another way to put it would be n by 2 into a plus n minus 1d. Why did I write like this? See, this is the last term, this is the first term, isn't it? So this becomes n by 2 times a plus the last term. Okay, so now basically we have given two formulas. Okay, one is this formula, very common. The second is this formula, very useful.